Hi class, so today what we're going to talk about is what's known as partial fractions decomposition. And again, this is going to help us do some integration problems, but the big idea here is partial fractions decomposition is not in and of itself an integration technique. It's actually an algebraic technique to help us break rational functions into summations of simpler pieces. Now that might sound a little weird or a little confusing, so let's break this apart. And where to begin, what is a rational function? So a rational function is actually just a polynomial function all over another polynomial. So in general, it's any function that looks like f of x is equal to some polynomial over another polynomial. So chances are you've been seeing lots of rational functions before. Maybe you just didn't know they're rational functions. So for example, we could say something like, say 2x all over x squared minus 2x minus 3. That is a polynomial, 2x sitting over another polynomial, which happens to be a quadratic in the denominator and just a linear function in the numerator. So those are what rational functions are. And these functions get really tricky when we start to integrate them. Sometimes we get lucky and a U substitution works, but many times more than not, we'll get to use partial fractions to help us out. And our whole goal of partial fractions is basically to say, can we take this rational function and make it into some summation of easier pieces to integrate? So hopefully what we're going to do is break this into individual pieces that are easier for us to integrate. That is the big story with partial fractions. And we'll go through an example in a minute just to kind of make clear what I mean by simpler pieces and that type of jazz. But the big thing we're going to be doing first is factoring denominators. So for example, in this case, we have over here on the right, this denominator factors into an x minus 3 and an x plus 1. And we're going to look at, well, depending on what types of factors we see in the denominator, will dictate what type of terms we have over on our right-hand side over here. So for example, I'll just list out these terms. We'll of course discuss these in more depth in class. We'll see things like distinct factors, like what we have over here, because x minus 3 is only raised to the first power, and x plus 1 is also only raised to the first power as well. We could see possible repeated factors showing up in that factored denominator, or we could see irreducible factors, like this one here, just for example, x squared plus 5. We can't break this into any two monomials, an x plus or minus a number times an x plus or minus a number. X squared plus 5 is as factored as that thing gets. The other things we'll see come into play today is we're going to be able to practice solving linear systems of equations, i.e., in other words, if we have a system of 3 equations and 3 unknowns, we'll practice solving for those 3 unknowns, or 2 equations and 2 unknowns and things of that nature. The other thing we'll get to do in this unit is practice our polynomial division. And this will happen whenever we're trying to factor or figure out what the decomposition of our partial fractions should look like. And the numerator to begin with has a higher power in it than the denominator, or greater or higher power equal to that of the denominator. Oops, there should be a greater than here. But in general, what this would be saying is if we have something like upstairs in the denominator or upstairs in the numerator, we have an x cubed, and downstairs in the denominator, we only have an x squared. We get to do polynomial division before doing any partial fractions. So check out the next video for an example of all of partial fractions together.